Alright, so strong and weak bases. A base that dissociates 100% into ions and water is called a strong base. Makes sense, right? So ionic hydroxides and metallic oxides are strong bases. So for example, sodium hydroxide will dissociate completely into sodium and hydroxide. Okay? A weak base does not dissociate 100%, which makes sense, and only a small percentage of the base forms ions in solution. So, for example, we have ammonia, okay, forms some of the ammonia ion and some hydroxide. And when again, we use the equilibrium arrow for weak bases. Now, we can tell the difference between them sometimes based on other properties, like whether they are a monoprotic or polyprotic acid. So acids that have only one hydrogen atom per molecule that can ionize are called monoprotic acids. So for example, HCl, HF, HNO3, okay, and CH3COOH. Okay, monoprotic acids can be strong or weak. Okay, acids that contain two or more hydrogen atoms, though, that can ionize are called polyprotic acids. Okay, so for example, H2SO4, H3PO4, and acids with two hydrogens are diprotic, with three hydrogens are triprotic, etc., etc. Okay, but when polyprotic acids ionize, only one hydrogen is removed at a time, with each acid becoming progressively weaker. So for example, H2SO4, okay, we're going to add that to water, we're going to get our hydronium, and we're going to get HSO4, the anion, okay? Then we're going to take that, we're going to add it to some more water, we're going to get another hydronium ion, and this time though, SO4 with a 2 negative, okay? Now, what is that are true for acids is also true for bases. So we have monoprotic and polyprotic bases. So bases that react with water in only one step to form hydroxide ions are called monoprotic bases. So for example, sodium hydroxide. But bases that react with water in 2 or more steps are called polyprotic bases. So for example, here we have some anions that are polyprotic bases. So they tend to be complex ions with more than one negative charge. So as with polyprotic bases, only one hydroxide is formed at a time, and each new base formed is weaker than the last. So for example, here we've got CO3 2 negative. We're going to add that to some water, okay, and we're going to get a hydroxide anion, and now we've added this hydrogen on that we've pulled off of the water, okay. And then we're going to take that, we're going to add it to some more water, again forming another hydroxide, and now we've got H2CO3 aqueous, okay. When we look at that, so our strong and weak acids and bases, and our polyprotic acids and bases, then we need to know what happens when we add them together. So the reaction between an acid and base produces an ionic compound and a water. So acid plus base gives us a salt and a water, where a salt is any ionic compound, okay? So the products of neutralization are both neutral, and that is why it has a pH of 7. In a neutralization reaction, or acid and base reaction, between a strong acid and a strong base, the product is always water, okay? So hydronium plus hydroxide gives us water, okay? And we will talk about acid and base spills in the next video.